Continuing in our discussion, here's just another example with the Pythagorean Theorem, and I say, hey, what's the length of the hypotenuse here? Well, again, this would say that 4 squared plus 7 squared equals question mark squared, or 16 plus 49 equals question mark squared. And so what do we get? 59, that's 65 equals question mark squared. Now, 65 is not a perfect square, meaning the square root of 65 is not a whole number. It would actually be an irrational number, but you can always use your calculator and do the square root of 65 if you wanted an approximation, and it'd be about 8 point something, 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 something if you wanted to round it off, but I don't have a calculator here. So on some homeworks, if you need a calculator, that's fine, but again, in this course, we do not use calculators on exams, and so a final answer, as the square root of 65 would be absolutely correct. Or I would give you numbers such that you could easily square root them without a calculator. All right, moving on. Pythagorean Theorem and trigonometry, which trigonometry just means the study of triangles, is one of the most useful things in applications and measurement. Comes up in architecture all the time. And so here's just a quick example problem where, say I'm building a house and my house is 20 feet wide and the walls are going to be 10 feet tall on the outside, but the overall height of the house is 15 feet tall. But if you want to build this house, you need to actually cut these boards. And so this question says, well, how long is that piece right there? And this is a right triangle Pythagorean theorem problem. So if it is 10 feet to here and 15 feet to here, then that means that this distance from here to here must be 5 feet. And if we are 20 feet overall, and I'm assuming this is a symmetrical house, then that means that this must be 10 feet from here to here. And so really, this distance is the hypotenuse of a right triangle. So we can say that 10 squared plus 5 squared equals question mark squared. So that's 100 plus 25 equals question mark squared. So question mark squared is 125, or that distance is the square root of 125, which again, this is an exact answer, perfectly fine for this course, but if you actually wanted to cut this board, maybe you'd need a calculator to come up with a better approximation. Sorry, a decimal approximation, not better. All right, so a few more examples here. Let's see. This just gets into issues on 12.8 of perimeter and area. This question says, we want something that has a perimeter of 24 units. So this activity has some issues with perimeter, and we're going to see those, and one of the issues relates to the Pythagorean theorem. So Johnny, in this case, drew this shape over here and said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And he said it has a perimeter of 24, which is not correct because a perimeter is a length, and these are square units. So what I've shaded in over here on the right is 24 square units, which is an area. It just happens to be like the area around the outside, but that is not a perimeter. If we were to actually see this perimeter, this is 1, 2, let's count it out. 1, 2, 3, 4, 5. Down 1 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we can actually see the perimeter would be 28 if we count up the whole length all the way around the outside. Perimeter is a length. It is not an area. All right. So this one involves the Pythagorean theorem. This was another mistake a student did. It said Susie was asked to draw a shape with a perimeter of 15 centimeters. And she drew this shape right here. And I think the logic is she went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And she said the perimeter was equal to 15. And that is not correct. we can see what the perimeter is and what the area is. Now, area is square units. So there's 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14, and that's just a half. So the area should be 14.5 centimeters squared if we're doing centimeters. Now the perimeter is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus this length right here. And that's what we need to figure out. If we have something that has height 1 and width 1, right? Height 1 and width 1, and it's a right triangle, what is this length right here? And we could use the Pythagorean theorem. 1 squared plus 1 squared must equal question mark squared. So that is 1 plus 1 equals question mark squared. So question mark squared must equal 2. So question mark is actually the square root of 2. So she drew something that had perimeter 14 plus the square root of 2, not 15. To draw something, well, I can't say to draw something. There's a lot of ways you could draw something with a perimeter of 15. But if you wanted to draw a rectangle, please note that whenever you draw a rectangle, this side plus this side must equal this side plus this side. So one common way of drawing a rectangle with any perimeter is to take to the perimeter and cut it in half. And then that must equal 1 length plus 1 width. So if I cut 15 in half, that's 7.5, which means this length plus this length must add up to 7.5. So take two numbers that add up to 7.5, like 5, 1, 2, 3, 4, 5, and 2.5, 1, 2.5. And now I have drawn something that should have perimeter of 15, right? This would be 5 centimeters and 2.5 centimeters because it only goes up to the middle, and 5 centimeters and 2.5 centimeters. Shapes don't always need to fall directly on the grid lines. Okay, so these ones, this is just going to take a second. For some of the homework, there's just going to be numbers 1, 2, and 5. Number 1 says a gate is 3 feet wide and 4 feet tall. How long is the diagonal support brace? That's very similar to a problem we've done. Number 2 says a boat anchor has a line that is 75 feet long and it's dropped into water that's 50 feet deep. How far can the boat drift from the spot where the anchor was dropped? So again, number 1 is part of homework. Number 2 is part of homework. And this picture looks like, here's the water. And there's a boat. And they've dropped an anchor. And the anchor is 75 feet. Sorry, that rope is 75 feet long. The water is 50 feet deep. And how far can they go from there? And the last question that you're going to be asked from this one is on number 5. And it says this is the profile of a greenhouse, which is 40 feet deep. So it's 40 feet deep. And they need to cover the roof of the greenhouse with some screening to block some of the light. And the question is, what is the area of this roof? Because once you find the area of the roof, you can find the square footage you need of this screen. Well, this side of the roof is a rectangle, and this side of the roof over here is a rectangle. And the area of a rectangle is just length times width. Well, we already know the width of this roof is 40 feet, so we really just need to find this dimension. And to do that, we got to use the Pythagorean theorem. So all of this comes down to, can I find this length right here? Now, I know that this is 20 feet, and I need to find this. But this is the same length as this. And so again, if I turn this thing on its side, the hypotenuse here is 20. And so I've got some value here, x and x. And I know that x squared plus x squared is equal to 20 squared. So that says 2x squared, and 20 squared is 400. Divide both sides by 2. It says x squared is 200. So therefore x must be the square root of 200. And again, you could use a calculator to find decimal approximation of that if you want, but once you know this length, you can find the area of this side, and then you can double that because we need to cover both sides of the roof. Anyway, numbers 1, 2, and 5. That is some of the homework for this section, and that is where I'm going to stop this video.